Yellowstone National Park is world-famous for its geothermal wonders, its wildlife, and of course, as the site of the supervolcano that could theoretically end all human life on Earth as we know it. And while it might be most famous for those massive explosive eruptions that have the power to bury much of the western United States under ash, the majority of the seismic activity at this particular park is actually pretty quiet. No, literally quiet. Since the year 2000, scientists have recorded over 2,000 small earthquakes in and around the Yellowstone supervolcano. But here's the thing, none of them have been felt by anyone. Not one person has ever reported feeling an earthquake in Yellowstone, even though there are permanent monitoring stations just a few miles away from where people live and work. So what gives? Why do these quakes go unnoticed, despite being so close to human habitation? Are they somehow hiding from us? This is Unveiled, and today we're answering the extraordinary question, why don't people feel Yellowstone's quiet quakes? Yellowstone National Park covers more than 2.2 million acres of land in the northwest corner of the U.S., straddling the border between Wyoming, Montana, and Idaho. It's best known for its geysers, hot springs, canyons, and most importantly, its volcanic activity. Yellowstone sits atop a massive magma reservoir formed by a plume of rock and gas rising from deep within the Earth's mantle. The magma chamber is about 45 by 25 miles wide and extends almost 7 miles beneath the surface. Now, it doesn't look like a big deal up top. There are no obvious surface features to suggest anything untoward going on below, but that chamber contains enough molten rock to fill up an Olympic-sized swimming pool almost 10 times over, and that's just a fraction of what's down there. If it were to erupt, which it won't, then the immediate area would be absolutely devastated, and large parts of the US would follow suit. A full-blown super-eruption would affect the entire planet. But thankfully, that kind of eruption is extremely rare, and we've got plenty of warning signs to watch out for. Lava lakes, earthquakes, and ground deformation, for example, are all ways that scientists can keep track of how the magma chamber is doing on any given day. In fact, it's these tiny tremors that allow researchers to get a better understanding of the inner workings of the mighty volcano. And they've been closely tracking seismic activity at Yellowstone since the year 1985, when the United States Geological Survey began recording data at the Yellowstone Seismic Network, or YSN. This is a series of local monitoring stations set up specifically to listen out for the characteristic low rumble of distant earthquakes, and particularly those occurring below Yellowstone itself. It's thanks to these stations that we know there have been 2,000 plus quakes rattling around inside the mountain in the last 20 years. But what's also interesting is that none of those quakes have been felt by anyone. The reason for that is because most of the rumblings are way too weak to be noticed by the human body. In other words, our perception of an earthquake, how strong we feel it to be, isn't based on the actual strength of the quake itself. That's measured in terms of magnitude. Instead, our perception is determined by something called the intensity of the event. How intense an earthquake feels depends on both the strength of the actual vibrations and how far away from the epicenter you are when they happen. When you hear about an earthquake that happened somewhere, but you didn't notice it at all, that means it was a really weak event, and you were far enough away from the epicenter that whatever vibrations did occur were unnoticeable. At Yellowstone, the quakes are both weak and fairly deep, which is why people don't feel them. In total, there are 4 main reasons why humans don't perceive these earthquakes. First, their depth. Earthquakes happen at various depths. The shallowest are the most common and the ones we're most likely to feel. But deeper quakes are also possible, and because they start off further away from the surface, it's harder for them to radiate outwards and be felt. Second, their distance from populated areas. For every 30 degrees of distance from the epicenter, the earthquake will be 10 times weaker. And if you're more than 60 miles away, you probably won't notice anything at all. Third, the actual strength of the quake itself. On the Richter scale, an earthquake of magnitude 3 or less is considered micro, between 3 and 5 is minor, 5 and 7 is light, 7 and 9 is strong, and anything over 9 is major. Most of the world's minor earthquakes are under a magnitude of 3. We can feel minor earthquakes from several miles away, but you have to be right next to a microquake to actually notice it happening. And finally, fourth, our own perception of the event. Some people are obviously more sensitive to earthquakes than others. You may also be more likely to notice a quake if you're outside at the time or if you're in a tall building. So when it comes to the earthquakes that have been rumbling away inside Yellowstone over the past couple of decades, all of the factors line up to ensure that nobody notices. They're usually pretty deep, several miles beneath the surface. They're very close to the epicenter of the volcano, a place with no permanent residents. And they're usually pretty weak too, with magnitudes between 2 and 3. All in all, they're essentially unnoticeable, even if someone were standing directly on top of them. And that's exactly what makes them so interesting to scientists. Because while it might seem strange that humans aren't noticing these quakes, they're actually really helpful to researchers studying the inner workings of the mighty supervolcano. You see, while it's great to have a network of monitoring stations to tell us about earthquakes as they happen, it's also nice to go back later on and try to figure out what caused them. By recording the exact time and location of each quake, scientists can build up a picture of the magma chamber below the surface. They're able to map out areas of higher seismic activity, which suggests that the molten rock is moving around in those places. And they're also able to identify any changes in the frequency or severity of the quakes over time. These are all important steps in predicting what might happen in the future. For example, in 1985, there were only 18 earthquakes recorded at Yellowstone, but by 2008, there were 2,000. This surge in activity led some to believe that a super-eruption was imminent, but scientists were able to allay fears by pinpointing the source of the increased activity, a newly formed magma chamber roughly 4 miles beneath the northeast corner of Yellowstone Lake. Then, in 2014, a different swarm of quakes shook the same area, again causing concern that a major eruption might be on its way. But by analyzing the data, scientists discovered that these quakes had actually come from a completely different source. They originated from the injection of cold water into the well. This was part of a geothermal project designed to harness the heat from the magma chamber below the surface. Once the water was pumped in, however, it caused a minor seismic response, something that wasn't anticipated before it was done. But now that scientists are aware of this link between wastewater disposal wells and earthquakes, they're able to take it into account in their ongoing research. In the end, by studying the swarms of quiet quakes happening beneath Yellowstone, scientists can better understand how the magma chamber behaves, whether that be through normal processes or in response to external factors. Right now, experts agree that a super-eruption is not imminent, but instead they predict that there will be smaller events in the near future. Steam explosions that blow craters into the ground and release scalding water and rock or lava that spills over the sides of the caldera. Whatever happens, the monitoring systems are in place to make sure we're kept informed. And all of those thousands of tiny earthquakes, the ones we can't feel, they're simply background noise in what is otherwise a never-ending story of fire and ice. Now you're welcome. Now stay curious.